Something strange about when you build software, you can build an application today, you can change absolutely nothing about the code for the next 2 years, and it can still become significantly harder, significantly riskier, and significantly more expensive to maintain. You didn't do anything to the code, nothing about the code changed, but ultimately that application and everything around it has changed in the background. From the date that you publish an application, the open source ecosystem continues to march behind the scenes, right? New vulnerabilities are discovered, new functions are released, and ultimately that leads to new minor and major versions that are not automatically included in your application. And there's this gap that continues to grow behind the scenes, like software depreciation. It's almost like the depreciation when you title a new vehicle. As soon as you sign for that new vehicle and you drive it off a lot, it's still the same vehicle as when you purchased it 15, 20 minutes ago, but now it's depreciated. That software depreciation is something that you're going to have to deal with. Whether you rely on Gartner statistics or another major published statistic, 80 to 90% of the code in most modern applications comes from open source packages. And again, this is an ecosystem that keeps moving behind the scenes, fixing vulnerabilities, releasing new features, adding cool new updates to new minor and major versions. When your application stays the same for 6 months, 12 months, 24 months, you're accumulating dependency drift. And that dependency drift is what I like to call version debt. So I define version debt as the gap between the software versions that your application is running in production today and the versions that it should be using to help maximize features and functionality and also maximize security. Skipped updates contribute to that version debt slowly, and over time you have a situation where what seemed like you were one minor version behind a couple months ago, now you're 3 major versions behind, and you're dealing with a lot of breaking changes and a lot of compatibility issues. And so now all of a sudden you're trying to struggle and you're trying to plan your way out to do a major update to your application. The second most prevalent conversation that was had at the Active State booth during the Black Hat conference was the idea of how can organizations prioritize the vulnerabilities that they need to remediate, the updates that they need to do, and is there a best path forward or a best way to do that? And I think when you look at remediating versus being proactive, I think we're asking the wrong question. I like to think about that question being similar to calling a plumber. You've got a leak in a pipe in your house, and there's a puddle of water on the floor. When you call the plumber to your house, you don't just stop and ask him to clean up the puddle of water on the floor without addressing the leaky pipe. And this version debt is ultimately the leaky pipe in the ecosystem that you need to have control over. You need to have some kind of proactive solution so that your organization is not back in a situation where there's more version debt accumulated in 6 months and you're asking the same question at the next major cybersecurity conference. Now, let me be clear about one thing, though. I am not suggesting that every application should automatically pull the latest update for any of the dependencies that are in its stack or in its code. That in itself becomes a major problem, and attackers keyed into that strategy a long time ago. And so that in itself exposes you to a lot of risk. So that's not at all what I'm advocating for. But in trying to quantify this idea of version debt and how to prioritize and how to look for things, right, the question that I kept asking is, if an organization has an application, how far behind typically is that application? And what vulnerabilities exist in that application today that they may have a JIRA ticket on that they can remediate someday, but how long has that exposure window lasted beyond when a fix was actually available for that package? So to help quantify that, I created a version debt check tool. It's published at the URL you can see here. And ultimately the tool itself helps quantify, how long have the open source dependencies in your application been sitting exposed with vulnerabilities that could have been fixed with an upstream release. You can add your own manifest file. You can type in specific package names and versions if you know those, or if you don't have a manifest handy, you can just select a general use case. And so just to show you kind of what we're looking at here, we can select the Python web application, and we can say that web application was updated or it's been static for the last 12 months as far as the dependencies go. And so what we're doing here is looking at the common libraries that would be included in a Python web application, and right out of the gate we can see that critical and high severities exist. They've been exposed, the critical ones, for a median of 279 days, the critical and the high at a median of 189 days overall. And when you look at the dependencies that I'm speaking about here, it's not just the top level dependencies. For example, Flask has a moderate vulnerability. It's been fixable for 173 days, but Flask also brings in 6 transitive dependencies with it that you may not have been explicitly aware of. And so that has a high severity vulnerability that was fixable 110 days ago, and a moderate severity vulnerability that was fixable 255 days ago. Let's take a look at another one. Celery, for example, was a clean package 12 months ago, and when you ingested or elected to use version 5.5.3, but it brought in 14 transitive dependencies, one of those being Click, and version 8.2.2 has a high severity vulnerability, and a fix has been available for 110 days. So that's 110 days of unnecessary exposure in your application, 110 days of unnecessary risk in your application as well too. If we want to take a look at a different framework, let's say we're looking at a Java Enterprise application, same time frame. We'll build a live sample off of that, and we'll see a total of 64 vulnerabilities that have a fix available, with a median of 101 days of exposure that your organization didn't need to leave that door open. Spring Boot framework, or the Spring Boot starter web comes in. It's a clean package, but it brought in 33 transitive dependencies. Apache Tomcat and Tomcat Embed Core 11.0.10 is a critical vulnerability that's been exposed for 101 days. Now, again, you may have a ticket for that. I know a lot of organizations use software composition analysis tools to keep eyes on the direct and the transitive dependencies. You generate your JIRA tickets and you try and get to them. But a lot of organizations that I'm talking to also end up having to push those tickets out because speed of development and existing sprints and project prioritization and delivering new features and functionality and driving revenue for the business, all of these things tend to take precedence over fixing CVEs and fixing vulnerabilities. So these are things that, you need to be aware of, you need to be cognizant of, and fixing those downstream vulnerabilities or cleaning up the puddle that's on your floor right now doesn't help shut off the leak. These vulnerabilities that you have tickets for, this puddle that you're trying to manage in your organization, if you're implementing AI and agentic coding, this puddle's probably growing pretty rapidly. The last video I talked about the idea that one organization has started pre-agentic development with 5,000 vulnerabilities in their backlog that they need to address, and now all of a sudden they're up to 20,000 vulnerabilities because of the dependencies that AI is suggesting and ingesting, and all the transitive dependencies that are coming along with those top-level dependencies without human eyes on what's actually happening there as well. So this acceleration is just going to continue to get worse unless you do something to close or put some guardrails on the upstream source. And that's how you stop accumulating this version debt. Instead of allowing your teams and your AI agents to pull from public ecosystems, you give them a pre-vetted, a curated catalog of known good packages built from source that you and your team control right out of the gate. That's how you stop the leak. And I would challenge you, if you haven't thought about that approach yet, to reach out, let's have a conversation about that, and let's stop this accumulating version debt.